Hi, I'm Steve. You can call me Steve. As a scientist, I use math a lot. Throughout my chemistry career, I was forever calculating masses of chemicals to weigh out or volumes of liquid to add to my reaction. At the end of the reaction, I'd have to calculate how much stuff I made and how much I expected to make. The neutrino experiment I'm on uses vast amounts of math to handle all of the data the detector spits out and extract meaning from it, in addition to all of the planning and measuring involved in just building the damn thing. Mathematics and statistics are vital components of the scientific toolkit, but they're not the exclusive domain of science. Math is also important in everyday life, from doing your taxes to splitting the bill at dinner. A lot of people are leery about math because they had a bad experience with it in school. They struggled with it, so they think they're bad at it. Those struggles could be due to any number of things, most of them beyond the control of the student. For example, insufficient funding and support for schools results in students not getting the proper teaching and attention they need to succeed. Older people may have also experienced the experimental train wreck that was new math in the States, which only succeeded in making math incomprehensible to everyone. Learning math properly requires a particular approach. Once you get past learning your times tables, math doesn't lend itself to rote memorization, which is a technique many students resort to. Word problems, the bane of most students, can't be solved by memorizing a pile of facts and figures. You have to actively think about them and extract the useful information from them, and then decide which equations you need to use in order to get the right answer. Algebra can be a little daunting as well, because a lot of people find it a little abstract to use letters instead of numbers. Because of this, math has acquired a reputation for being hard. This becomes a self-fulfilling prophecy, because students go into it assuming it has to be difficult to understand, and then have a difficult time understanding it. It doesn't have to be this way. Here's an example. Say you're in the grocery store shopping for cereal, and you don't really care which type you get. You just want to get the most cereal for the least amount of money. We're also assuming you're not shopping for children. You've narrowed it down to two options. Fruity Nuggets come in a 450-gram box and cost $5. Cavity clusters are $8, but the box says 600 grams. They're different prices, and the boxes are different sizes, and now everything is a swirl of numbers. Step 1, relax. It's going to be okay. Step 2, read the price labels more carefully. The store may have saved you some trouble and displayed the price per unit mass, or how much 100 grams of each cereal costs. If you're in the States, rather than grams, it might be displayed in ounces, or grains, or pennyweights, or some other archaic unit. The important thing here is to compare equal amounts of cereal to get a clear picture of how the prices compare. To get the most cereal for your money, buy the one that costs the least per unit of mass. In our example, the Fruity Nuggets are 11 cents per 100 grams, and the Cavity Clusters are 13 cents per 100 grams. Fruity Nuggets win. If the labels don't show that information, you can figure it out yourself. These days, everybody except me carries around a magic phone with a calculator built into it. You can simply divide the price by the mass on the box to get the cost per mass. But what if you can't remember which is which? I assume nobody wants to try and watch this video while standing in the middle of the cereal aisle. This is where units can help you. First, let's look at the symbol for division. It's a horizontal line with two little dots, one above, one below. Those dots represent the numbers you're dividing. When you say, for example, 10 divided by 2, the 10 goes on the top and the 2 goes on the bottom. Whatever you're dividing by is the thing on the bottom. In the case of our cereal, the units we're looking for are dollars per gram, which is another way of saying dollars divided by grams. Anytime you encounter the word per in a mathematical context, it just means divided by. If you're to write it out, the dollars would be on top and the grams on the bottom. We're dividing by grams. The thing you're dividing by goes on the bottom. Now put the number associated with the dollars on the top and the number associated with the grams on the bottom, and do that division to get dollars per gram. I used per 100 gram earlier, but that was just to make the results look prettier. It's the exact same calculation. Word problems can look challenging, but if you sort your units out first, it can show you where you need to go with your calculations. When I teach a class or tutor an individual student, this is one of the first things I talk about, and it's the most important thing I say. If you take nothing else away from this video, take this. Sort out your units and they'll sort you out. I'm not the only one advocating for math. Danica McKellar has written a whole series of books aimed at getting girls past the barrier of thinking that math is something they're not good at. It's not true, they're good at math. They just don't know it. Danica is also one of the few people with an Erdos-Bacon number. I've got one, it's a little sketchy. That's math. It's not an arcane, impenetrable black art that only eggheads and Poindexters can understand. It's something you can understand. Nobody's expecting you to do integrals in your head. I know I can't. But an understanding of the basics can help you manage money better and also makes it harder for people to fool you with numbers. Thanks for watching. I've been Steve.